Kevin Van Geem is full professor at the Laboratory for Chemical Technology at Ghent University, and he's the coordinator of the eLECTRO project. He is a former Fulbright research scholar of MIT. He directs the pilot plant for steam cracking and pyrolysis, and he was recently awarded with the PRC Advanced Grant. Thermochemical reaction engineering in general, and in particular the transition from fossil to renewable resources, are his main research interests. Kevin will introduce you now to the eLECTRO project.
So I have the honor to introduce you to the eLECTRO project. So eLECTRO started almost more than 3 years ago, while the project writing. And the main concept there was electrification and plastic waste. So that's these are the cornerstones of this project. And the objective was there to drastically reduce CO2 emissions, but also making something that's economically viable and that's scalable and transferable to other continents. And we have a very nice group of companies, research institutes that are collaborating. So Ghent University is the coordinator, supported by Prime. Prime is a pyrolysis recycling technology company. Then we have Coolbrook, which is the electrified steam cracking company. They are based in the Netherlands, but also connected to Finland, where we also have VTT, and VTT works in extrusion. Ariston is they do the LCAs and TEAs of this project. They're based in Luxembourg, and then we have also Engie Laborec based in both Belgium and France, together with Van Geem, who help with the management. And then we also have Polytechnico di Milan and Aristotle University, who look at modeling and experimentation of this in this project. Last but not least, we also have Borealis, which is of course our industrial demonstrator. And in this project, we don't only go to low TRL level, we also do high TRL. So that's a bit unusual of a European project, not only small scale, but really also large scale. So the center line is this part, plastic waste, all the way back to plastics. Well, that's what we do. We are very lucky also to have a lot of other companies following us, like Total Energies and so on, which are industrial advisory boards. We just had a meeting this morning with the board, providing us advice. But you see the different elements in this project. Because of time, I will not dwell on that too much. But the 4 ambitions are very clear. And for me, enabling electrification is, of course, crucial. 100% utilization of renewable energy sources. If that energy is green or has very limited CO2 emissions, then we can get really a reduction of 90% of greenhouse gas emissions. So those two are actually coupled. What we want to create is, in this case, high-value olefins, but this means olefins that we can use for making polymers again. And this means olefins with high purity, 99.9% for ethylene and propylene. We start from plastic waste, but mixed plastic waste, so not easily sorted, because we really want to have something that's scalable. And we know that this heterogeneous waste is available in large amounts. The very nice amount of waste probably be mechanically recycled. Our impact, well, of course, what we wanted in this project is to demonstrate this for European base case, but also illustrate the potential in Asia, for example. And that's why we have a collaboration with, for example, you get in Korea. They will provide this plastic waste from Korea. That actually seems to be nicer waste than the one that we have in Europe. So it was actually a bit surprising. But that shows that the technology is actually transferable to other continents. And the same we will do with other waste from different continents. And this way we can help to look at current petrochemical centers and where they are located today, and give advice if this maybe is the best place for them in the future, or if there are other alternative places that are better suited. Voilà, this is what I wanted to say about eLECTRO.